Hello, everybody. Welcome to Wonder House. Are you learning a lot at Climate Day here at Wonder House? Great. Well, we have a real treat for you now. We're going to introduce Dr. Joellen Russell and Dr. Beth Tellman. And let me tell you a little bit about both of them. Joellen is an oceanographer, climate scientist, and university distinguished professor at the University of Arizona. And her research uses robot floats, satellites, and supercomputers to observe and predict the ocean's role in climate and carbon cycle of the past, present, and the future. So Joellen's work on the westerly winds led to a big discovery and the creation of a new paradigm in climate science, namely that warmer climates produce poleward intensified westerly winds. And this insight solved a big climate paradox. The mechanism that's responsible for transferring 1/3 of the carbon dioxide in the atmosphere into the ocean and then back out again during our repeated glacial and interglacial cycles. So Joellen is one of the authors of the Climate Scientist Amicus Brief in the landmark 2007 Massachusetts versus the EPA Supreme Court decision that ruled that carbon dioxide is a pollutant covered under the Clean Air Act and should be regulated by the EPA. Joellen is presenting today with Dr. Beth Tellman, and Beth is a human environmental geographer at the University of Arizona who seeks to address the causes and consequences of global environmental change for vulnerable populations with a focus on flood risk and land use change. She joined the faculty of the University of Arizona in 2021 from the Earth Institute at Columbia University. And she's been working to develop satellite-based flood insurance indices for cities. She also is supporting ACT Today, Adapting Agriculture to Climate Today for Tomorrow in Bangladesh, to examine and improve existing financial instruments to decrease flood impacts on flood systems. Beth previously co-founded Cloud to Street, a public benefit corporation that leverages remote sensing data to build flood mapping and monitoring for systems for low and middle income countries. And so both Beth and Joellen are climate scientists, but importantly, like many of you in the audience, they're parents, specifically moms in their case. And we all know that the future generations depend on us for making good decisions today about where and how to develop human society and to protect our planet for future generations. So they're going to tell us today about how harnessing the power of big climate data can help us make better decisions for our cities, our countries, and our homes. So let's welcome Joellen and Beth.
Thank you.
Thank you.
Thanks. Hi.
Well, all right. Thank you for joining us. All right.
Oh, hi. Thanks.
Yeah. It's Arizona, the Wonder House in Austin. We are so glad to be here. We've been dying to tell you all about climate data is power to the people. Not a joke, it's a real deal. Let us show you how. So everybody knows we're on this tiny little spaceship Earth. Carl Sagan was the one who told them to turn around Voyager and look back at our home. And you know, we found thousands of planets around other suns, and we're the only one that we found that's blue. The only blue planet. So I, of course, want to talk about this gorgeous blue planet that we live on. It's blue because 72% of the Earth's surface is ocean. And that ocean is what keeps Tucson and Austin from getting much, much hotter, much, much faster. And I want to tell you about it because as an oceanographer, don't get seasick. It's very hard work going to sea. It is, okay, imagine a mountain of water, right? So I'm on a 300-foot ship. That's the size of a football field, right? Chug, 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 chug up the side of a wave in my ship that's the size of a football field. Shush down the other side and dig the prow into the next big mountain of water where it proceeds to land on you. And on a good day on the bow, and you remember you're like 5 stories up from the ocean, from the water, it's just a little spritz, spritz, right? No problem. You've all been out on a boat. It could get a little worse. If on a bad day, it might be blue. You've got so much water going over the boat, it's now blue. Now we've got all the sides going, uh-oh. On a really bad day, this one is not even that bad because I was always, not feeling very well by the time I got to a bad day. The water is black. You cannot see the sky anymore. So we've actually had an amazing convergence of weather and climate modeling. It turns out that all of our old weather models used to not include the ocean. Yeah, I know how lame that sounds, but they didn't include an ocean. And our weather service, so the European Center for Medium Range Weather Forecasting added an ocean, a coupled ocean atmosphere model. We call those climate models, just by the way. In 2004, you want to know when the US National Weather Service at NOAA did? 2018. We're a little bit behind. And by the way, that last picture, that was not, everybody always goes, that's such beautiful satellite imagery. I'm like, no, not satellite. Beth's going to tell you all about satellite data. That wasn't satellite, that was simulation. That is the new weather model, coupled ocean atmosphere, land, sea ice, soup to nuts. And this, of course, is our high-res ocean, just so everybody, no, not satellite. There is no satellite data in this. This is just math. Math, supercomputers, and, little sparkle and glitter. This is what I'm working on right now. I know. We are, at the University of Arizona, we are the first and only university in the world to compete with the national modeling centers of every major country in the world. The only one ever. We submitted our data.
Yeah.
That was a lot of hard work. Did you know our supercomputer is bigger than the one at Stanford? Public Research University, Stanford can suck it. I'm sorry, oops, am I being recorded? Thanks, Bobby. So that's us over there. There's all the national modeling centers, but that one right over there next to Beth, this one right there, that is the University of Arizona. Only university in the world to be able to pull this off. Because we're trying to do better prediction, oh yes, we stand on the shoulders of giants always, but most people don't realize that I stand on the shoulders of a Nobel Prize winner. That's Suki. Suki Manabe won the Nobel Prize for Physics last year for his climate modeling work. And of course, that's me on a bad hair day. Because can anybody tell which one is there's one of these is the real Earth from satellite, and the rest are climate model simulations. Anybody want to guess? Pick. Anybody? No volunteers.
This one?
Well, and it's changing. So we're using these, okay. So,
Ooh.
yeah.
What's all this red?
That's
Whirling.
carbon emissions. This is the NASA satellite, OCO2, measuring carbon dioxide from the atmosphere. Those are our emissions. Some of them are from wildfires, but most of them are from us burning fossil fuels. I know. That's a little scary. Oh, dear.
It's getting redder.
So, this is what's happening to the forcing for our atmosphere, what's making it warmer and warmer. This is the radiative forcing from NOAA. You can see that almost all of it is carbon dioxide. This blue is methane. That's not nothing, but it's not growing anywhere near as fast as the carbon dioxide. So I like to do not just climate and weather modeling, but Earth system modeling, which means carbon accounting. Because, of course, we know what the atmosphere is really, really well. We want to know what the land is doing, but we need to know the ocean. And just so that everybody knows, this is a good news story. Did you know that the United States has dropped 22% off their peak carbon emissions? Dean Garzioni was just saying that our brief was the only brief cited by the Supreme Court when they ruled that the Clean Air Act actually does cover carbon dioxide as a pollutant. Well, that was in 2007 in April, and our drop started in 2007 in September. I know, I actually think that's kind of cool. We're dropping faster than any country on Earth. And basically, we're doing it because saving $1 and of the planet. Sustainability and prosperity go together here. Every time you don't emit a carbon molecule into the atmosphere, you're probably saving money on your gas bill. Yep. Kind of awesome. So this is what happens with all that CO2. It basically, Earth's radiation budgeted experiment, ERBE, my favorite set of satellites. Okay, except for the one I'm building. I'm trying to get NASA to give me a new satellite. They are proving to be a little recalcitrant. We whiffed, but we're going, we missed the $200 million satellite, meaning we put it in and we did well, but we didn't do well enough. And so I just told them flat, so if you won't give me the $200 million one, I'm going to ask you for the $400 million one. Give in now or it'll be $800 next week. So basically, most of that excess energy is going into the ocean. Now, how do we measure that? How do we look at that? Is it a satellite thing? Actually, no, it isn't. And of course, what little there is staying in the atmosphere is making us all hotter, making our summers longer, making them hotter, and contributing to, okay, we're also cooling our stratosphere. And if anybody's ever wondered what the polar vortex looks like, here you go. This is what it looks like. It is the big jet that wraps around. We have one of these in the northern hemisphere too, and boom, there it is. That is the big jet. That's our ozone hole, which I know everybody heard it was healing. Did you know it lasted till January 6th this year? It's supposed to end in October, and it lasted till January 6th. And we had an Arctic ozone hole 3 years in a row over the past few years. It's serious. So when I look at that and I said, well, the winds are increasing, and everybody's like, really? Like those little blue dots, I know they're in there. Even if you're in the cheap seats, you should be able to see them. That's where the winds aren't increasing. Everywhere else, the winds on planet Earth are speeding up. This is a worry. If you're an oceanographer, it means, what are we doing? We're stirring the ocean harder. And the ocean is telling us that, in fact, it really is. That's the mixed layer depth. Everywhere it's blue is where it's deeper. I know, and this is a 30-year trend. This isn't like just happened last week. This is all of it. So, and this is our shipping, just in case anybody's worried about, supply chain issues with bigger waves, bigger winds, bigger ocean stirring, crazy. I'm like, really? It's getting worse? I think it's time to send my students out to sea instead of me, right? Don't worry, we're doing it. Oh, that's Becky Beedling, who's now a professor at Temple University, but once upon a time, she was my grad student. That's her deploying one of our robot floats into the ocean. I said, how do we know? I'll tell you. We're using robot floats because we have fewer ships than we used to have to do this research. Yeah, can you believe that? Less investment by the US into ocean research right at the same time it's getting hot and wild out there. Yeah, that's a little cranky making. But these are awesome. What they do is they sit at about 1,000 meters, 10 football fields down, and then when they're ready to make measurements, they drop down to 2,000 meters and then make a profile of measurements to the surface using microsensors, little tiny sensors that don't take very much energy. And it's amazing. Everybody's like, oh, look at CubeSats. I'm like, did you know we use these in the ocean too? It's true. We use these tiny microsensors. We have 6 sensors plus chlorophyll to look at the plant food. We look at the oxygen level. We look at it's amazing. And carbon, of course, the pH of the ocean. So, oops. There it is, dropping.
There it goes.
Exactly. I'm actually, it's kind of boring. You can't really see these. That's why it's a cartoon. Because they come up to the surface, they beam all their data back by Iridium satellite in a 5-minute burst, and we put it online immediately for the entire world to use. The weather forecasters, the Navy, the oceanographers everywhere, the ecosystems people, the fisheries people, everybody uses these. And we started out with 0 of these biogeochemically censored floats in 2014. I came here to the University of Arizona. I'm a little older than Beth. We started this in 2000. I wrote a white paper in 2010. And in 2014, we started deploying these. The National Science Foundation and the National Oceanic and Atmospheric Administration fund us to do this. And not just this anymore. Ready? This is where it is now. We have a global array of floats worldwide with international partners like Australia and France don't even ask me about the German floats because I hear about that German engineering, and yet their floats die first. It's annoying. No. We're 90+% of the floats on this map because, well, we're good at it, and and National Science Foundation gave us the money. So and there's the data.
Ooh, what are they measuring here?
This is actually oxygen in the ocean. These brown should be green because they're at the surface, right? With lots of oxygen available. Yes, lots of oxygen available, but no, the upwelling is so fast from all that extra wind mixing, they're undersaturated. They are low oxygen water that is basically the rot of ages. I know. They told me not to say poop and dead bodies, but that's exactly what that is. So we have a global array now that's giving us data from all over the world in real time that everybody can use. Hey, power to the people. We're also assimilating it right here at the University of Arizona. On our fabulous supercomputers, we assimilate that data. Where you see the little dots, the difference in the color is the simulations in the background, the model, and the actual observation is in the little colored dot. And what we found was, when we run the model forward to the future, is if we add a bunch of new wind, so red is where the CO2 is coming out of the water, blue is where it's going in. We would like it to go in, right? If we add 20% increase in the winds, which I think is modest, we get a massive outgassing of carbon dioxide from the deep ocean. That rot of ages that's almost 800 to 1,000 years old comes to the surface.
So I can't just take all our carbon and store it in the ocean?
Yeah, all the people who do ocean carbon dioxide removal, I'm always like, so if you put it in, my winds are going to burp it back out. Maybe we should measure that before we start, spending money on that, eh? So the New York Times did a fabulous interactive and front page story on this work just last December. It's pretty exciting. And they actually used data held at Cyverse, which is right there at the University of Arizona. It's National Science Foundation again, but they used the data that they found of ours on that server to do this amazing interactive so you could actually see the upwelling. I know. Henry Fountain wrote this article and got help on the animations. It's amazing. So now I'm trying to add a satellite right here because I need more wind measurements in order to get to here. Got the floats, need the satellite, working on it now. My last proposal, they actually let NOAA said that I could take one of their P3, they gave me a letter commitment, said that I could take one of their P3 Hurricane Hunter planes to New Zealand. I know. Somebody asked me what voodoo doll I had to use for that. It wasn't, I just asked nicely.
I'm taking notes. Ask nicely, get plane from NOAA for research.
Exactly.
Next year.
We should talk. So why do we care about this in Arizona? We're worried about heat waves, right? There's the footprint of extreme heat. We're worried about droughts. Who here, even in Texas, we're worried about droughts. But even more so if we have a home, we're worried about floods. This is from the Rolito, not far from my house in Tucson. Yes, that is an upside down car.
And yes, it floods in the desert.
Exactly, it does. And this is why. This is La Nina, right? We just had a triple dip La Nina. Why? Again, the winds are stronger. This massive cold tongue is due to the winds being stronger. You can see how much stronger they are. In the blue is when it's stronger, and in the red it's when it's weaker. Over the last 25 years, the winds have just picked up. And that means that it's changed the behavior, which, Beth, what does that mean?
It means more flooding many places in the world.
Oh, no.
As we're warming the planet and the oceans, the atmosphere can hold a lot more water. And when that comes down on land too quickly, we get the type of floods that we've been seeing more frequently just over the past couple of years. If we warm 2 degrees, we think we're going to double the amount of flooding. If we go up to 3 degrees, it might quadruple.
Oh, no.
So we better mitigate
I hear California's getting another atmospheric river tomorrow.
Yeah.
I thought they'd had enough, but apparently you can't turn it off.
Yeah, the levees are already overtopping in some places in California. You've been seeing that on the news. Our infrastructure just isn't built to handle that much water. This is a simulation that we did with my company, Floodbase, which I'll talk about in a minute. But we work with machine learning and satellite data to create near real-time flood maps. Every 3 hours, we can do anywhere in the continental U.S., and this is our maps from the flooding that happened just over December and January. But it's not just California that's flooded.
Ooh.
We were also mapping the floods in Pakistan. If you remember hearing about that in August, a third of the country flooded. The maps that we made from satellite data were featured on CNN. And these are really, really important maps to get right to figure out where does aid need to go from floods, who needs help, how big of a problem is this. We were also making flood maps of Hurricane Ian, third most costly disaster in U.S. history in Florida.
I have friends in Florida whose houses were hit by Ian. I bet some of you did too, right?
And people aren't getting the payouts they need from insurance to rebuild. We've got a big, big problem with the amount of water. All of this light blue that you're seeing is water that we captured from satellite data that we can map in these events. Warmer oceans, a warmer planet means bigger, badder, more frequent hurricanes. So that's a problem.
That's a lot of blue.
It's a lot of blue. Too much water. But
good news!
I have some good news. I'm not all bad news. But we know that climate adaptation works. And we have data and the ability to adapt. If we were able to increase insurance coverage in the US by another 50%, we could probably absorb most of the damage from climate change and tropical cyclones. So we've got options here.
Excellent. Tell me.
Every dollar that we invest in adaptation, we'll save 7.
Oh, I love saving 7. Tell me more. My kitchen table needs to hear all about this.
So because so much of flooding is uninsured right now, actually 97% of flood damages have no insurance. That makes it hard for people to rebuild, makes it hard for real estate markets to function. People in developing countries have had to sell off livelihood assets like cows and livestock, pull kids out of school to survive these events.
Wait, go back. You said hurts a real estate market? You mean the price of my house?
Oh, yeah.
Oh, no.
Oh, yeah. This is actually a picture in someone's front yard in Houston after Hurricane Harvey, who didn't have
insurance.
Yeah, that they just painted on cardboard. So we have a protection gap. And one way that I'm working on solving that protection gap is with satellite data. So satellites circle the Earth every day, everywhere, and we can get images to map floods, like in these images here. In blue, that's the floodwater, to know who needs a payout, exactly when. We can price that risk with the same data. You can remove the process of litigation, adjusters, all that expensive stuff that happens now in insurance, and use data instead. So you can provide insurance cheaper to more people anywhere in the world.
Outstanding. Tell me more. Oh, I love this plot. Can I come play with this?
Yes. This is the Global Flood Database. This is our open access data from almost 1,000 large maps, large flood events that we've mapped around the world. You can zoom in, pick different countries. One of my colleagues, Colin Doyle, who's sitting over there, built most of this database.
Woot! All right.
I'll bring Colin up again, but
yes.
Yeah, Colin helped build this database, and anyone can download this data for free. And we can also use machine learning to fuse together multiple satellites to reconstruct flooding anywhere on Earth. So this is a time series of 2 decades of flooding in Bangladesh, and this can be used to price and underwrite insurance too.
You're saying you're doing the math.
Yeah.
That's awesome.
We do the math. Yeah, we use long short-term memory networks and convolutional networks for the nerds in the house. Those are the
Oh no,
AI
we're the nerds.
Yeah.
Absolutely.
I know, you're
That's right.
the nerds.
This is South by Southwest. It's full of nerds.
Okay, a lot of the flooding that we've been mapping that's in the Global Flood Database is in South and Southeast Asia. Millions and millions of people exposed. That number is growing. People are moving into floodplains and rebuilding in those places. We've got to adapt. And we can. These are images from some of the private commercial satellite sensors we use. This is from PlanetScope. This blue and brown here are different composites of what water looks like when it floods in a city. This is San Pedro Sula, Honduras, from Hurricane Eta and Iota. And what we do is we label this flood data, and we use it to train machine learning algorithms to make maps in near real time.
So an insurance company should just look it up and go, oh, it's orange. They got flooded. Here's your money.
Yeah.
Awesome.
Yeah. The blue, actually, but yeah.
Excuse me.
Yeah. We want money to go to the who
Not
actually
the dry
got
ones,
flooded.
the wet ones. Yes,
The wet
okay,
ones.
got it.
Money goes to the wet ones. And we also work closely with NASA in my lab at University of Arizona to make sure their algorithms are as good as they can possibly be, and that publicly available flood maps are available to everyone.
I love it. Power to the people.
Yeah.
Let's do it.
But I don't just work in an academic context, writing papers and making maps and data. I'm going to do more than that to solve the climate crisis. So with Colin Doyle and my CEO, Bessie Schwartz, we started a company about 8 years ago called Floodbase. We just closed our Series A round of funding.
We actually practiced for this talk on Zoom because she was in New York.
Lower Carbon led our round. We also just announced this past week we're partnering with FEMA to help them reshape how they do claims management to try to make it more based on satellite data to get money to people quicker.
Love it.
Who need it.
Love it.
So we're doing that work now. We're working in the private sector. We work with insurance companies. Our data is used to underwrite the largest data-based insurance program in the world in Colombia. It insures 140,000 farmers. So it's happening. We're changing how insurance happens and how disaster recovery can be. We're adapting.
Ooh, and real-world applications. I like it.
We also are the official flood mapping partner for the United Nations. We work together with organizations like the World Food Program to help them understand if there are refugee camps at risk and if they should be relocated. This is a map of refugee camps in the Republic of Congo. One of them we found on satellite data had flooded 3 times in the past 30 years, and we said,
ouch,
might want to consider relocating that camp. And they were really glad they did, because the next year, that place flooded, and 10,000 people could have been impacted by that event. So this is real-world, life-saving data here.
Amazing.
This is a picture from South Sudan from floods that just happened this past year, where we were able to see on satellite right where the dike broke and the flood happened, and help the World Food Program understand exactly where the aid needed to go to reach communities that needed it.
Very important.
But we got to do more than that.
Even more.
We got to mitigate climate change. We have to adapt to climate change. But we also have to think about climate justice. We got to think about the rules that are written and the inequality and the environmental racism that affects who gets hit hardest by these events, who haven't even caused most of that emission in the first place. Nope. So, I've been working in Texas, actually, with the Texas Rio Grande Legal Aid and my student, Lucas Belluri. This is down on the US-Mexico border in McAllen. And what we've been doing with them is helping them use satellite-based flood maps so that they can rewrite the rules. Class action lawsuits, actually, they've successfully sued FEMA, proving that they've discriminated against Mexican-American communities and gotten money back to people who need it after disasters. And we're going to help them do it faster and change those rules.
I love this. So basically you're saying we're going to save money, save property, and save lives. I love it. Can't be any better than that, right? So I want to point out, we've had some challenges. Doing the academic side, she got her phase A, but academically, we've been disinvesting in ocean research and in climate research for a long time. I bet you didn't know that your taxpayer bucks are going to, well, everything but climate and earth research. I'm quite serious. This drop is ongoing. It's not good. We're less than 5% and still dropping. And I want to tell you why this kind of science is so important, because it's played an incredible role in American history. This guy, Walter Munk, is the most famous oceanographer you have never, ever heard of. I love it. Walter was one of my professors at UCSD, at Scripps Institution of Oceanography, and he was the last call that Eisenhower made on D-Day. He's the one who gave him the information to make a good decision on what day to go. And the reason is, Walter is the one who wrote the equations that I'm using, new edition, but the version of the equations that related wind speed to wave height. Why did that matter for D-Day? Because the gunnels on our landing boats were low. The gunnels were low. If the wave height got over 6 feet, they would swamp and our soldiers would drown before they even got to the beach. And Walter wrote those equations. I got to see him at one of his last talks before he died at the Ocean Sciences meeting, and about half the oceanographers in the world were there. Now, you're all like, ooh, that's a lot of people. I'm like, no, it actually isn't. Do you know there's only about 6,000 oceanographers out of 8 billion people on planet Earth? Yeah, when I said they disinvested in research, I wasn't kidding. There aren't enough of us. But Walter got up in front of half of all the world, including me, and he said, Hitler was my generation's greatest challenge, and we beat him. Climate change is yours. Not too big a challenge there. Not too big a standard, right? And honestly, you could have heard a pin drop. My heart, he said, hold the line. You must. I know there aren't enough of you. Hold the line. The people will come. You will get help. There will be more. We will build what we need to build. We've done this before. We can do it again. And we can. I hope you're getting out of this talk that there is optimism, innovation, and leadership happening already. You're down 22%. You are down 22%, and I bet you didn't even know it. And we've got people like Beth doing these amazing things, right, for our whole planet with the new simulations and the new floats. And why do we do it? Well, you know, we're moms. This is what we do. We want these little guys to have the safe, secure, prosperous future that they deserve and that we grew up with. So thank you. Climate data is power to the people.
For all our people. Great job.
And we'll take questions, heckling. Come on in. The water's fine. Sure. Oh, we need a mic. They told us.
Yeah. Thank you. I'd love to ask more about climate justice, because I love that example of, you know, holding FEMA accountable, but I'm thinking more proactive measures, because there's been a lot of talk about more disaggregated risk maps will just allow insurance companies to price gouge communities who don't have enough money to move and avoid that higher risk, that higher insurance premiums. So are you engaged in any more proactive efforts to use those maps to help get those communities the funds they need to move to lower risk flooding areas, anything along those lines?
Yeah, so thanks, great question. So we need kind of this whole suite of options when we think about climate justice, and we need way more than insurance, of course. Insurance is a really great solution when you have this sort of mid to extreme event, sort of rare frequency flooding. But when it's flooding all of the time, insurance isn't the right option. Relocation is. So in the United States, there are some programs for managed retreat, but not even close to the amount of funding that would make that process possible. Indigenous communities in Alaska and in Louisiana have been trying really hard to lobby to get more funding, and we really don't have enough right now. So we need major policy changes to really think about how are we going to do managed retreat in a just way that respects the agency of those communities and how they want that process to undergo. So we have a lot of relocation to do.
And the
in
new
many
Earth
places.
system models we're running now at 3 kilometers resolution. Now that's not your house or your block, but 3 kilometers is down to the human level where we can start talking about where those hotspots are going to be, not just where they are now. Because we know that unless we bend that CO2 curve, and we're on our way, but unless we bend that CO2 curve, we're going to see even more challenges. So, absolutely.
Yeah, and we are starting to see some exciting things happen. You know, the EPA has just released a lot of funding for climate and environmental justice. So I'm hopeful that we'll be able to build these coalitions with data, scientists, community organizing to really shift where the money is going and change that. But we got work to do.
Other questions?
Hi, I'm Steve Amos with the nonprofit Health Code. If the planet's not healthy, we're not going to be healthy. Fantastic job. A question, Joellen?
Yeah.
Doctor, when you
Joellen.
showed that image around Antarctica of all those things that were brown, what's the indication for that, the implication for lack of oxygen, plankton, and therefore life in the ocean?
It's like you're writing my next research proposal. Thank you, thank you. No, actually, we're right in the process of writing a third follow-up to our original 2 grants that got that global array. And what we're focusing on is the change in greening in the ocean. On land, more CO2 can mean more plant food, but in the ocean, they have plenty. They don't need any more. In fact, more CO2 tends to make it more acidic, and changes in circulation are changing the distribution of oxygen. Now, when you bring that old, rotted water up to the surface, it tends to take more up. So in fact, we predicted other folks predicted that the ocean was really going to deoxygenate, and that doesn't look likely. It is happening where we've got polluted runoff from agriculture with too many nutrients, but in the global ocean, what we were worried about was it going stagnant. But I showed you what the winds look like. No, did you know that every major boundary current in the world has spun up? Well, okay, except for the Labrador current, which Greenland is dumping fresh water onto. But every major current is sped up. This is an extraordinary moment in the planet's history, and we're watching it in real time and trying to figure out what happens next. So, yeah, I'm writing to the National Science Foundation right now about looking at the change in greening and the patterns of productivity, because as our season lengths are changing, so are our growing seasons in the ocean. It's a big deal. Stay tuned. Next talk. Others.
Thank you very much for what you do. You're helping save the world. At the same time I ask this question, while we need environmental justice for FEMA to help support those who have been flooded, at the same time, we are still building homes, and we've rebuilt million-dollar homes on some islands who have been reimbursed by FEMA. How do we balance this? And stop bad behavior where we're building homes that are too risky?
Yeah, great question. I mean, this is part of why we've got to rewrite the rules.
Climate data. 2 words.
Yeah.
More climate data.
So
because we don't write the regulations, we don't make the policy and legislative decisions, right? We can encourage, we can inform, we can give you the data to make wise decisions from your own kitchen table. But this is, at some point, we have to actually scale big decisions. And that might be at your town council, it might be at your state legislature, it might be at the federal level. But we're spoiled because Arizona is the lowest hazard state. But go ahead, Beth, you probably have a more informed answer.
So, I mean, it is true that FEMA flood mitigation grants, recovery funding, goes to wider, wealthier communities because they have the resources to navigate the system, apply for funding, a lot of the decisions that get made are based on cost-benefit ratio, which is incredibly harmful for marginalized communities because lower-income communities are deemed as not worth investing in. That's actually the major reason that the Pajaro levee right now in California didn't get rebuilt for years. It was actually slated to be rebuilt this summer, and the rains came a little too soon. So we've got to reshape our calculus of what communities we're investing in and the criteria we use to do that, and change the rules of how many times you can rebuild your house with FEMA money. I think it's like up to 6 times in many places. So that's a rule that we can change. And we've got to do a lot more work getting involved politically to think about. That's the hard work, I think, of climate and environmental justice.
Is we are, as scientists, we can do all this great research, publish it, build a company based on it, do awesome and amazing things, but really to make big legislative change, we need the people to do it. We need regular folks to speak up, to vote, to talk about, and use the climate data in all their different interactions, right? Not just, kitchen table, but at your workplace, at the town council, at the PTA. All of these are places where we can help make change, but we need everybody to lock arms, right? I get a little cranky when I think about Walter, and I think, so we've got all these people saying, oh, we can make a deal with that climate change. We can work it out. It'll be fine. Don't worry about it. They're only going to take, most of Miami due to sea level change. They're only going to take, but it really matters that we speak up, right? That, if you're doing something that, if you're swapping, right? You're swapping carbon polluting for non-carbon polluting anytime you get a chance. Every single human can do this, right? Make it, thrifting so that you're give something a lifetime longer before it hits the landfill. Switch from a gas stove to electric. Switch your electricity from coal to renewables or nuclear, anything that's non-carbon polluting. You can swap, share about it. Whenever you get your new tankless water heater that's way more efficient, put it on Facebook, blow up your group chat, tell everybody about it, because this is how we make it okay. We encourage it, we make a movement, right? That 22% didn't come out of just big companies. It's more like Dunkirk with, where they pulled 300,000 troops off a shore without the big warships, right? They did it with little tiny boats, right? I'll take 5. I've got 12. I can get 3, right? They didn't take 10,000 at a time. They took 1 and 5 and 7, and they came in the night in their little boats all by themselves. We are the little boats. We are doing this. We need to move faster. Sorry.
A lot faster. Other questions? I don't know who's the mic.
Hi there. Thank you so much for the work that you're doing. This is so important, and for sharing it with us. Us in this room, I would say probably a majority of us who are here at this talk are a bit more well-informed. But I heard you say, Beth, that you've worked with CNN on getting some of this data into their hands. How are you, A, working to get that data into more places where the broader public can hear it, and then B, helping them understand it, because not everybody has the depth of climate knowledge that most of us in this room probably do?
Yeah. Thanks. So, we have started to get this data into the media more, but I've also started to work more with NASA and make sure that their flood mapping and operational systems are better. And that's one of, I think, the best ways that we can get this out into the public. And we have to do a lot more education to translate those types of tools so that anyone can use them. So, in addition to mass media, we are working with public institutions. A lot of the data that my company makes and that my lab makes is publicly available. So if you check out the Global Flood Database that Colin helped build, he designed this really amazing dashboard where you can really interact with the data, zoom in. You don't have to be a scientist
Super easy
to use it and understand. The other thing that we really learned, especially working with disaster relief agencies, is a lot of times they don't want to map. They don't want to like zoom around and look for the flood on a map. They just want a WhatsApp message that says 2,000 people in District A, go there. And so we've sort of gotten away, actually, this is Colin's phrase, graphs not maps, or like text messages not maps. And how do we distill that data into this really kind of actionable piece of information? So we do a lot of that work too, directly with decision makers, mapping out, okay, where's your decision point? What lever do you need exactly when? And let me give you that information as simply as possible to make that decision.
My solutions are nowhere near as high-tech and awesome as hers. I'm a co-founder of a group called Science Moms, which is 12 climate scientists who also happen to be mothers. And we do basically just the facts at sciencemoms.com. And so this year I went on Kelly Clarkson. It was awesome. Just by the way, Nathan Fillion was on, and he is... Oh my God, I have a I aim to misbehave sticker on the back of my scooter. Loved it. And also things like I do some climate commentary on Good Morning Arizona. Amber Sullins has me on every once in a while to give the climate component to her awesome sauce. So we're reaching much bigger audiences through more media and more like Science Moms is just straight up just the simplest, most straightforward, where here's my mom village who's been helping me out raise my 2 cutie babies for so long, and I've been that slacker mom, you know the one, that's me. And here we just wanted to help with what we can offer, help them make those kitchen table decisions, and get them activated to help us change the world so that our kids get the summer times they deserve and not Del Scorcho. So yeah, we're working on it, different perspectives, but absolutely everything we can do, including laying down on the road if required. And what's kind of awesome is we've been really supported in the mission we have by our colleagues in our departments at our university. And President Robbins, you gonna come up and say hello to everybody? It is pretty extraordinary being at the University of Arizona, which is a land-grant institution that has that extension mission, and we're supported in doing the full mission, not just to our students, not just to some fancy nature paper, but to everyone, to the people. It is really our job. It's what we mean to do and what we're supported in doing, which is extraordinary. UT Austin also has some amazing work in that direction. I have some amazing colleagues there. But we're working together at these public research institutions to try and get that data out to the people who need to make these decisions and make them quickly. Anybody else?
Yes. I was going to ask if you were focusing on flood and water, and coming from Arizona and hearing how the Colorado River is drying up and shared by 5 major stakeholders, and there are other parts of the country that are becoming quite arid. Is there a counterpart to you that is working on the arid side?
Oh, yeah.
Yeah.
Heat waves are, Tucson is the 4th fastest warming city in the nation. Our friends up the street in Phoenix are the 5th fastest warming city in the nation. And number 1 is Las Vegas, all of whom are right there in the Colorado River Project's deliveries. We are absolutely worried about it. I was just talking, I'm the chair of NOAA's, the National Oceanic and Atmospheric Administration's, their Science Advisory Board. I'm the chair of their climate working group, and they met on the Tucson campus just last week. This is a big deal, and it's going to take, they have a new NIDIS, it's their National Institute for Drought, that was put into congressional appropriations and is working on our behalf now. We had some suggestions, but yeah, this is a big focus, absolutely.
And there's a lot of great climate tech companies working in the drought space too. Climate Engine is one that immediately comes to mind for me NASA also just launched a new satellite in December called SWOT. It's the Surface Water Ocean Topography Mission, and it's going to really help us measure water levels in rivers and reservoirs and manage water a lot better. Yeah, but there's a lot of really great science and organizations working in the drought space.
Some of our East Coast colleagues, though, tend to forget about us out west. They tend to think that it's just heat and humidity and not actually massive drought that we're about, what is it? Whiskeys for drinking and waters for fighting. That's where we are.
Hi there. My name is Deandra. I'm the executive director of an environmental justice organization called Intersectional Environmentalist, or IE for short, because it's a little bit of a mouthful. But we create educational experiences and resources for BIPOC youth, Black, Indigenous, and people of color. And a big part of our work, which I'm really glad to be in a room full of a bunch of what I guess we're calling ourselves nerds. I like that. We often find in our work that people on the science, tech, and history side often have such great insights into what stories are missing. And then the storytellers have such great insights into what data they wish they had so that they could tell more powerful stories. So my question to you both, and anybody who's willing to talk to me about it after this, is what stories with the data that you have do you wish were being told for the next generation?
Ooh. Oh, I'm all about mitigation. I think that the little boats are coming in and taking us off by handful, and that really needs to be supported by American leadership. This is not just it's not just an individual thing, it's a national leadership thing, where I feel strongly that we as a country, if we want to provide better information for the world, for those communities in Bangladesh, et cetera, those are satellites. Many of those satellites are ones that she's leveraging from NASA, which are funded by taxpayer money, right? A lot of the work almost all of the work I do is basically funded by us. I mean, we are 64% of global ocean funding is just the United States. The rest of the 183 countries on planet Earth provide about a third. I mean, now that means that we have this huge role to play, and given our emissions history, that's a fine place for us to be in. But we were 22% of global emissions. We are now 13% of global emissions. And if we stick on this trajectory, we will have cut half of our total global carbon emissions from the US by 2032. Just this trajectory, just doing what we're doing, little boat by little boat, we'll hit 50%, and we'll be 6% of global emissions. I see this, how do we make it cheaper and easier for everyone in the world to both live, be prosperous, save their families, and do better for their grandchildren? We lead. We get out in front, we innovate, and we share it open source with everyone, which we're doing. And I think it's just I get so worried about our babies and their despair. There is an epidemic worldwide post-pandemic of despair, of people, despair-driven diseases like alcoholism and drug abuse, but also suicide. And they're sad and they're worried that there's no hope. There is hope. We're doing it. We're doing it right now. Come on in. The water's fine. Up, my babies. Up. It's okay. We'll be all right. We promise. We love you. We're looking out for you. And you can help look out for your kids too. Come on. It's just, that's the thing I want to say.
I would say I want to hear more stories about adaptation and innovation that we're not hearing. You know, Bangladesh actually is one of the leading countries in climate adaptation, has so much to teach the world. And I want to get those stories out there and get us inspired and really sharing knowledge in a different way. The work you're doing sounds really amazing, and I think for the climate justice movement to be successful, it has to come from these lessons and history of the environmental justice movement, and really figuring out how we weave and tell those stories to innovate. That's the work.
I'd also like to hear more about like in Arizona, we have 26 native nations. I would love to hear, they're doing amazing things out at the Tohono O'odham and the Navajo. I mean, it would just be amazing. I mean, my very dear friend, Professor Carletta Chief, is leading our Indigenous Resilience Center at the University of Arizona, and I love her. I love her work. Oh my God, I cannot tell you how much I consult with her on my next projects because I want to make sure they matter. And her voice is one that everybody should be hearing. We live in such a wonderful time. I mean, we're not just at a state university, right? We're Hispanic serving and Native serving. It's amazing. So come on in, the water's fine. Got any kids who need a degree? Because boy, have we got the degree for them. Anybody else?
Hi, my name is Ash. I'm kind of new to this sector, and it's really awesome. I didn't know this community actually existed.
Woot!
So it's really cool to kind of see that.
Welcome!
I have a maybe off topic, maybe a tech question, maybe a very deeply personal question. My parents are looking to move to Savannah, and then I heard a story on CNN about how Savannah soil is pretty much crap and it floods. So I showed him. I found a platform called Flood Factor, and I showed it to him. I didn't know about your platform. I would love to show him your platform too. How would you explain climate or flood, pardon my French, to an asshole that doesn't want to believe in climate? Sorry.
We do this all the time. I'm sorry, but have you talked to my uncle? I mean, I got an uncle, a cousin. Oh, my Aunt Rose. No, quite seriously, it's so she'll talk about the flood part, but for climate change, it's really easy. Come look at my float. It'll show you the ocean is hotter. That's just a flat fact. It's not one float, it's hundreds, right? Our atmosphere with the warming, the 10 top warmest years happened in the last 12 years. That's it, right? We're here already, and a hotter atmosphere can hold more water. It's super simple. Hotter atmosphere holds more water. That means that not only does it make us droughtier where we don't have water because it tends to evaporate it, Arizona, God, do we know that part, but it also means that when it does rain, it boom, it comes out like crazy. So my hot ocean is feeding her floods.
So that's sort of relationship that Joellen was talking about. For every 1 degree of warming, we get 7% more moisture the atmosphere can hold. So it can rain that much more. So these events like Hurricane Harvey, that was actually a very slow-moving event, that stalled over Houston. They are range of estimates, but 20 to 50% of that rainfall they think was related to climate change and a warming planet. So there's the actual amount of water that can fall is larger, and it totally changes the game in flooding. And that's shown in every study that we've done on that topic for the past 30.
My dad says the ocean these days is like a box of chocolates, right? You never know what you're gonna get. You can blow that surface layer off, right? Just blow it off, and you might get cold water, maybe. You might get an incredibly thick warm water layer. And that was what fed Harvey. We thought it would just be a little temperature anomaly. Nope. It was endless. 400 meters of hot water that Harvey had access to. So normally a hurricane blows by, it cools the surface of the ocean and helps reduce the size of the hurricane. Instead, he just kept pulling and pulling and pulling. And these are really straightforward. It's even my Aunt Rose can see it, unless she doesn't really wanna.
I mean, we've had to throw a lot of hydrology laws out the window because what we used to call the 50-year flood, the 100-year flood,
is the last week flood.
Yeah, what is, they call it in hydrology non-stationarity. We have to rethink how we do statistics because we're changing the atmosphere and the planet so fast. Insurance companies are trying to figure out how the heck do I do pricing now and take care of that risk with climate change. So we really are seeing every industry have to rewrite the rules and adapt to this reality.
Come on in. Anybody else?
Yeah, I think I'm next. Whoa, that's a,
Yeah, the water's
I have
really
a
warm.
question, or I wanted to make a comment, I guess. It's funny, he says he's recently in this space. I did my freshman engineering project on electric cars because our post office delivered the mail in them. So that's a long time ago.
Oh my
And
goodness.
it wasn't really called anything at that point in time.
Saving money.
Yeah, it was a good thing to do. But what you just said, about the positive things, that made me want to speak up. I'm kind of focused on something else, gamifying financial education, but it goes in the same thing, gamifying sustainability.
Yep.
I really want people to look at, not looking at gloom and doom. That's motivating, but it also can make people shut down and just go into avoidance. So if we can gamify it, if we can have reward and recognition and competitions and celebrate the successes like you were just doing.
I'm dying to be able to. This is where I'm moving. If I get my satellite, it allows me to get from the 76% of the total carbon from the ocean to 96%, at which point I close the carbon budget and I start publishing weekly estimates of the top 10 economies' carbon emissions.
Yeah.
Weekly.
Well, the thing is, most
And
people...
once we've done that, I want them betting on it on the Las Vegas line.
Yeah.
I'm not joking. I want their, they'll bet on anything.
But my point is that most people can't get into this. It's just too much for them. But telling them, use a low-flow shower head, and here's where you can buy it, and and here's why, in bite-sized chunks and have a competition.
Every
that's
carbon
where it
molecule you don't emit.
So I just want to put it out to this space because it's something that I've been championing for a while. I really want. And one other thing, so I'm coordinating Citizens Climate Lobby, Texas Lobby Day.
Yay!
But everybody.
Yeah.
So I'm still involved. I'm just not involved all the time. But everybody, go to cclusa.org. I really, no matter where you are, it's usually a federal lobbying group, and we're just focusing on Texas for obvious reasons. So.
Wonderful. Thank you.
Oh, is the mic on? Oh, yes.
Sorry.
Go ahead.
I'm from Montclair, New Jersey. I'm a professor at Montclair State, and I'm also the environmental director for my township.
Woo!
New Jersey has 0 stormwater utilities, and I'm doing a feasibility study for this. What is your take on stormwater utilities as a way to mitigate and adapt to stormwater and flooding and all that?
Ooh, I actually don't know a lot about stormwater utilities. Tell me more.
Like utility, where we collect a fee for it, but we separate it from Public Works or DPW. And it's specifically for flooding, because we've been hit by Ida.
Oh my God.
New Jersey is not immune to flooding and storms. So.
Yeah.
Well, I wasn't sure if you...
One big gravel sponge for the Appalachians.
Yeah.
Yes. Sorry, I used to work at Princeton University.
Yeah, I haven't worked on stormwater utilities. This is the first time I've heard of that, but we definitely, stormwater is a huge part of what we have to think about with flooding, especially in so many of the older cities in the U.S. when we have these combined sewer outflow systems, and when we get floods, we get water quality issues. One of the reasons, actually, Jackson, Mississippi had water problems this summer was because there was a flood that flushed contaminants, so much so that they couldn't filter the water fast enough. So all of these water problems are related, right? So managing stormwater is super important in managing floods, but I'd love to hear more about your work. Let's talk.
Well, one more?
She's got it. Last question.
Okay, so maybe we close off with something positive.
All right, let's do it.
Because that's kind of what I'm seeking with my question. So my name is Marcela. I work for Replenish. We work building circularity for recyclable materials around the U.S. We do this with data. That's why I'm here, because I thought, right up my alley. But I'm less a little, more worried than ever, because I live in Miami. And in that, map that you showed, like my house is right there. And the blue part. And I know it, we make the joke over there that you should have a boat, not a car. Like we always make those jokes. I know flooding. Over there, we're working with a nonprofit called Debris Free Ocean. Love them. You should reach out to them. But basically, they're working with NOAA and with a grant. And what they're doing is they're educating low-income communities that are affected with floods to reduce their plastic waste. So they connected that way. So I'm curious, I know of that project, but I'm curious, do you know more of the initiatives that NOAA or other organizations are having in Florida to, I don't know, protect us, avoid us dying soon? I don't know.
Well, the waste management is actually super sexy. I'm really serious. The debris in the ocean is almost entirely flooded off from land and river mouths. The U.S., fortunately for us, our waste management's actually pretty good, and we are only about half of 1% of the total. People complain because it's only 6 river mouths in Asia, Southeast Asia, that provide almost 90% of the plastic that gets into the ocean. But debris, of course, is incredibly important because it fouls our whales, it damages our fisheries, it wrecks our reefs because when you cover them up with plastic gunk, they can't photosynthesize. This is really damaging. You find them in the bellies of sea turtles that have died and in seagulls and other things. I'm an ocean nut, so I pay attention to this. But it's the sexy topic of waste management, right? The full life cycle, meaning we don't just need to keep track of our carbon molecules, we need to keep track of our landfills. And it's really important. Now think about this. You take oil out of the ground, right? We make it into plastics. Some of what we do is use plastics. We then take those plastics and make sure they are carefully put back in the landfill, right? We got to use them, and there is 0 impact to the atmosphere and a small impact, especially if you use a previously created brownfield, no impact to anyone. We're using something we've already kind of polluted to put our very carefully back in. Folks in the rest of the world particularly, but here in the US, there are many places where we're not doing that fully. And the recycle, reduce, reuse is such a wonderful concept. But I also am a big fan of reburying the stuff we took out. Put it back in, don't leave it in the atmosphere. I am anti-incinerator for that reason, because no more CO2. The best, cheapest, most efficient way to not make it hotter on planet Earth is just don't burn it in the first place. So efficiency saves you a buck and the planet. Woohoo! Thank you. I'm so glad you're working in that area. And I think that was all we had time for, but thank you very much for coming. We appreciate your energy. Woohoo!
Yeah.
Good one.